you know the concepts, the process is too simple for the explanation. So coming to the explanation, okay. So and lab is a, as I've been told, okay. So it is a simple method for producing the composite materials, okay. So in this case, a mold must be used for and lab parts unless the composite is to be joined directly to the another structure, okay. So we're going to use the molds. So the mold can be simple as a flat sheet, okay. It may be the flat sheet, or it may have the infinite curves as well as the edges over there. So depending upon the application, we can able to select the flat surface or as the curved surface. So it is a production technique suitable for prototypes and low volume production of fiber composite materials. For the demo purpose, we want to show out for the students, we can able to use this particular technique over here, okay. So the composite part will have a nice smooth surface on one side and a very rough one on the other side, okay. So on the starting phase, we're going to have the smooth finish. At the other end, we're going to have the rough finish because of the fiber and the resin impregnation. So coming to the working condition, okay. So how exactly it's going to be worked over here, okay. So before before layup process, the mold is prepared, okay, with the release agent to ensure that the part will not adhere to the mold. So once the mold has been placed, we have to be ensure. So whether we have to ensure the mold should not stick to the composite structures over there. Okay. So in order to avoid that, we're going to use some material on the surface of the mold. Okay. So like in the end of lab, we're going to use the sand in between the molds. Okay. So that the removing of the mold, it will not cause any sort of damage over there. The same process over here also. Okay. So now to remove the parts, we're going to use some release agents so that the mold will come easily over there. Okay. So the reinforcement fibers can be cut and laid in the mold. Okay. So the reinforcement fibers may be long fibers or it may be the cut fibers. Okay. So initially it is laid on the mold. So after that, the resin bath. Okay. The resin must then be catalyzed and added to the fibers. So once you're going to pour the resin on the fibers with the help of brush, we're going to brush it throughout the fibers, or else we can use the rollers to roll out throughout the surface of the fiber and the resin. Okay. A brush or roller or sequence can be used to impregnate the fibers with the resin. The layup technician is responsible for the controlling the amount of resin and the quality of the saturation. Okay, the person who will be doing over there, you'll be responsible for the even for the quality also. Okay, if you follow the correct thing, you can able to get the good quality of the product. So the main advantage is the cost of this thing is very less. Okay, the cost of the production equipment is very low. The disadvantage is it is bit time consuming. Okay, we have to leave it uh, for some solidification. Okay, it will take a lot of time. So environmental problems may arise during the working process due to the pouring of the liquid resin. Okay, so there may be some environmental problems over there. So this is about the and lab process. So any doubts in the and lab process? So is there any doubt in the and lab process? Kindly reply, is there any doubt in the and layer process?
No, sir.
So this is a simple process to obtain the composite structures. Okay. So in order to go in depth over there, okay, your Naveen sir has been doing the PhD on this process on this composite materials itself. Okay. So they are using the and layer process over there. If at all, if there are any batches under the Naveen sir is doing this project, you guys can able to check it out. The and layer process has been doing it practically for his workpieces. Getting the simple and layer process. They have been using it in order to obtain out the structure. So this is about the and layer process. So next we'll be moving for the so this is the filament winding process. Okay. So filament winding process. This is the next concept. The filament winding process. So in this filament winding process, you guys can able to check it out over here. So it's going to have the continuous roving in other words, the fiber, okay, the continuous roving fibers. We're going to have the pulleys to pull out the fibers from the rollers, and then we're going to have the resin bath. So whatever the fibers have been pulled has been dipped in the resin bath. So after the resin bath dipping, we're going to have the again the rollers which has been passed over the carriage, okay. So this carriage can able to move towards as well as the away. You guys can able to check out the direction of the moving of this pulley, okay. So in wherever we need, we can able to move it and we can able to rotate it. So this is the drive box where this is called as the mandrel. This mandrel will be rotating continuously. For that rotating mandrel, the fiber will be uh, uh, mixed over there and it's been rolled over there now to get the required shape of the mandrel. So we're going to show what is the main application of this filament winding process, okay. So these see, like these cylinders we can able to do it, okay. So like these cylinders we can able to do it, how the fiber will be oriented over here, okay. So this is been done with the help of the filament winding itself. So this is how it's going to be work, and this is the diagram for the filament winding process. So coming to the explanation, for the filament winding process. So actually the filament winding is a fabrication technique, okay. It's been mainly used for manufacturing of open cylinders or closed end structures, okay. If you guys have seen the pressure vessels or as the tanks, okay. So for those cases we can able to use this filament winding process, okay, especially not to develop the open cylinders, okay. So in this case, the process involves the winding filaments under the tension over the rotating mandrel. As I've been shown the mandrel for you guys, the rotating mandrel, okay. As the fiber has been pulled out and has been oriented on this mandrel, it will rotating it continuously. Get it? So tension of the rotating mandrel. The mandrel rotates around the spindle, okay. It will be rotating in the axis 1 and axis 2, okay. In the horizontal as well as in the transverse directions will be rotating it since not to get the desired surface finish. So the laying down fibers in the desired pattern are angled to the rotational axis. So as I've been told, the man has been rotating it continuously. Okay, we have to be adjusted out so that the fibers will be placed in all the process over in all the edges over there. So the most common filaments are glass or carbon, okay, and are impregnated with the resin by passing through the resin bath. So as they are wound onto the mandrel, okay. So the common type of filaments which we're going to use in this case is the glass filament or carbon filament, which has been dipped in the resin bath before it's going to be wound onto the mandrel. So once the mandrel is completely covered to the desired thickness, okay. Once the mandrel has been covered with the desired thickness, the resin is cured, okay. So depending upon the resin system and its characteristics, often the mandrel has been autoclaved, okay. It has been reheated, it's been opened out, it has been autoclaved, it's been reheated over there, or else it may be heated in the oven, okay, or it may be rotated under the radiant heaters until the part has been cured. So whichever the process you can able to use it in order to curing the mandrel over there. So once the resin has been cured, the mandrel is removed or extracted, leaving the aloe final product. So that's what I have been shown over here. Okay. So the mandrel will be removed over here. So by leaving out the aloe part over here. Okay. So this is the part which has been obtained through the filament winding process. So this is about the filament winding process. Okay. So this is the how the filament winding process is going to be work over here. Okay. So we're going to show the textbooks. 1 minute. One minute. We in the meeting. So we're going to show. See, in the textbook also the same thing, the same process. The overall the things will be the same. Okay. The feed roll, the continuous strand, the pulleys is going to mix with the resin bar, After the mixed resin bud has been placed under rotating mandrel to get out the parts. Okay, so this basically has been used to obtain the pressure cylinders, the storage tanks, and the rocket motor bodies. Okay, so this is how the application of in this case this filament winding process. So next we'll be moving for the powder metallurgy process. Okay, so we're going to tell the how we're going to see the powder metallurgy process. Okay, so there's a lot of application of this powder metallurgy process. Okay, so in the current thing there is not been used in all the research center this powder metallurgy techniques. So 1 minute. So 1 minute, we're going to give the brief introduction for this powder metallurgy. I'm searching out my PPT. So 1 minute, I've been searching it out. 1 minute. So so we covered the two important topics: the filament winding process and the and lap process. So next we're going to start with the introduction for the powder metallurgy. Okay. So what exactly the powder metallurgy and what are the numerous applications of this powder metallurgy and all. Okay, so basically powder metallurgy process, okay, is a metal forming process, okay, performed by heating a compacted metal powders. Okay, so it actually a metal forming process has been obtained by heating the metal compacted powders to just below their melting points. Okay, we're going to heat the things below their melting points. Okay, so this process has been there for the past 100 years over the past century because it's a superior way of producing the high quality of parts in the present situation for the numerous applications. Okay, so the main advantage of this process offers over the metal forming technology such as the forging and the metal casting is the shape complexity. Okay, we can able to get the better shape complexity. Next, near a net shape to the dimensional control. Almost the net shape of the product can able to be done over this in this case. Okay, so that's why the powder metallurgy has been quite famous in the present scenario. Next, we're going to the so historical background of the powder metallurgy process. So when it's been developed, from when it's been using over the years. So this was the history of the development of the powder metallurgy. Okay, so in the 3000 BC itself, it's been where has been origin of this powder metallurgy has been taken place in the India as well as in the Egypt. Okay, so it has been used for the sponge iron for tools and other implements. Okay, it has been used in those periods itself. Next, in 1200 AD, cementing of noble metals. Okay, so especially in the South America, this process has been used. So after that, in the 1718 one has been used in the France and Germany. So later on, coming and the days has been gone. So this how it has been produced and how the research has been done on this powder metallurgy process. Okay, so late in the 1990s, okay, so we've been developed the metal matrix composites. Okay, this has been used by using the sintering process itself. Okay, So basically, after 1830, the majority has been used in the United States. Okay. So we're going to tell what are the main important steps in the powder metallurgy process. Okay. So these are the four important. So this thing is very important for the examination as well as for your IA point of view. So the steps involved in the powder metallurgy process. Okay. So these are the four important steps that has been involved in the powder metallurgy process. Okay, the first one is the powder production, the compaction, the sintering, the secondary and other finishing operations. So these are the four important operations which have been involved in the powder metallurgy process. Okay, so this is a very important concept, the powder metallurgy process. So wait for some time. We're going to take out the attendance part. So in the next class, we're going to finish out the powder metallurgy steps and its applications. Along with that, we're going to complete out the future trends of the powder metallurgy, present and the future trends of the powder metallurgy process. Okay, the three important concepts will be covered in the next class.